Hi everybody, my name is Emily and I'm going to be telling you a couple stories about canine domestication tonight. So before I start, full disclosure, I am a PhD student in a marine biology lab, so I'm not exactly an expert on this topic. However, I've worked with dogs for the past 10 years or so, so it's a pet interest of mine. I just think domestication is neat, and I'm hoping at the end of this talk you will too. And because this is Nerd Night, drinking game, I've stuck some of these cave art friends throughout my talk, so drink every time you spot one. And if you are looking for an excuse to finish your drink and start a new one, keep your eyes peeled for this little dog wearing a hat. He's hidden pretty carefully, so you gotta look. And with that, something people have in common globally is that we really love domesticating things, and we've been doing it repeatedly for thousands of years. So we domesticated around 40 animal species and 150 plant species from all around the world, and as you can see, some of them date back very far. So the species that dates back farthest of all is the domestic dog. So if you live with a dog, take a second to consider that there are up to 40,000 years of history leading up to your canine roommate. To put it in perspective, Homo sapiens have been around for maybe 200,000 years, so dogs have been with us for almost a quarter of that time. Just to give a little more of a timeline, we start seeing the first dogs showing up in art around 4000 BCE. Going back to around 12,000, 13,000 BCE, we start seeing the first deliberate burials of dogs, and the first skeletal remains we can attribute to dogs and not wolves. And according to recent genomic evidence, dogs genetically diverged from wolves sometime between 20,000 and 40,000 years ago. So because this all happened so long ago, it's hard to say how exactly they were domesticated, but there are a few theories. So one is that some wolves started to scavenge around human camps, basically snacking on anything that humans discarded as waste, basically garbage wolves. Another is that the relationship started as mutual hunting partners. So both theories basically boil down to this scenario where you have populations of humans and populations of wolves. For the most part, the wolves are too fearful or aggressive to approach humans. But just due to natural variation, you have some that do venture a little closer. There's then selection for these bolder wolves. They're getting extra food from trash heaps or hunts, and possibly protection from other predators who don't like people. So you end up with more wolves venturing slightly closer. This goes on for enough generations, and eventually you get wolves closely associating with people. And people decide that this arrangement works pretty well for them too. So on a genetic level, dogs and wolves are the same species and share 99.9% of their DNA, but there are some pretty profound differences genetically. So studies have found differences in genes related to body size and skull development, starch digestion, synapse formation, as well as genes in the cortisol, adrenaline, and dopamine pathways. And these are all hormones associated with stress response and fight or flight. So some of these genes might have to do with the behavioral differences between dogs and wolves. So dogs are much better at reading human facial expressions and cooperating with humans. Though interestingly, they're worse at cooperating with other dogs than wolves are with other wolves. So basically, dog domestication has been this long-running, very successful experiment. And in the mid-1900s, these two scientists, Dmitry Belayev and Ludmila Trut, wanted to see if we could do it again, but this time on the scale of decades instead of thousands of years. And they would embark on, quote, arguably the most extraordinary breeding experiment ever conducted. So starting out with some historical background to set the scene, in the USSR in 1940, this guy named Trofim Lysenko was pretty much calling the shots in terms of biology research. This guy totally rejected Mendelian inheritance and natural selection. He was all about grafting plants together and cold shocking them to see if they produced stronger offspring. And Soviet propaganda portrayed him as a genius who was revolutionizing agriculture. So at the time, genetics was considered a fake science, and Soviet scientists who refused to announce it were fired. Hundreds to thousands were imprisoned, and several were actually executed as enemies of the state, including the brother of this man on the right, Dmitry Belayev. So Belayev worked as a scientist helping fur farms, breed foxes and minks with better coats, which is very lucrative. He was a geneticist, and he tried to disguise his work as physiology to stay under the radar, but even so was dismissed as head of his department in 1948 for his geneticist leanings. So despite all of this, he had some really burning genetics questions related to domesticated animals, specifically these traits that crop up in domesticated animals, such as spotted fur, keep showing up in totally unrelated species. And the going theory was that people specifically selected for all of these traits and all of these animals, but that didn't really make sense to him. So instead, his hypothesis was that humans had only selected for tameness and that these other traits just got dragged along. So basically, that behavior could be genetically linked to many other traits. So to answer this question, Belayev decided to try experimentally domesticating foxes. And in 1952, he approached a colleague named Nina Sorokina with his idea at the fox farm she worked at in Kokila, Estonia. So he asked if she could come up with a test for calmness around people and foxes, then breed the calmest foxes together. So basically, just like in wolves, he was trying to increase the frequency of this slightly calmer phenotype. So Sorokina was pretty skeptical that this would go anywhere. Farm foxes were very fearful and aggressive. If you had to handle them at all, you had to use these big 2-inch thick protective gloves. Another scientist on the project described them as fire-breathing dragons. They were not nice. But Sorokina was game to try. She and her workers began testing the foxes. A few were slightly less agitated around people, so they selected those ones to breed. And by 1955, which is just 3 generations later, a few offspring from this line were more or less indifferent, being approached by people. This was super exciting for Belayev because this was happening way faster than he anticipated. And keep in mind, this was all absolutely illegal, and they did their best to disguise it as physiology research instead of genetics research. So after Stalin's death in 1953, attitudes towards genetics slowly began changing. There was a lot of genetics going on in the rest of the world at this time, and it was starting to reveal Lysenko as a fraud. So in 1957, Belayev took a new position at, and I'm going to mispronounce this, but Akemogorodok, which is basically this huge academic complex. So genetics was still illegal, but he was going forward with his project to study a larger scale fox experiment. And he hired a researcher by the name of Ludmila Trut to head it up. And I just want to take a second to talk about how much of a badass Trut is. So Belayev warned her that the work was illegal, for starters. It might take decades without producing any results, putting her career on the line, and that it would mean moving to the middle of the Russian wilderness with her husband and new baby. And she basically just said, no problem, I'm in. So in 1958, she packs up and moves to Lesnoy, where there's a fox farm with thousands of adult foxes, along with a dozen or so they shipped over from the pilot project. And this new experimental farm down here on the right enabled her to set up a control group. So with the experiment in full swing, almost immediately they start seeing these crazy things popping up. So in 1961, many of the foxes are still pretty close to this fire-breathing dragon stage. There's a few that will tolerate human touch. As the experiment goes on, they start seeing the tamer foxes breeding a few days earlier compared to the control foxes, and foxes who would wag their tails at being approached by people. 2 years later, they're seeing foxes actively seeking attention from people and soliciting belly rubs. In 1967, they start seeing the Shiba Inu tails that curl up over the fox's back. They also notice that the pups are opening their eyes and ears a few days earlier than the control group, and they're seeing this kind of extended puppy behavior where the adults continue playing and even involve humans in play. So this sets Trut and Belayev thinking that this suite of traits has something to do with timing. So maybe something is changing when genes are getting turned on and off. Excuse me. And then in 1969, we start seeing foxes with these spotted coats, like in lots of other domesticated animals, and floppy ears. And keep in mind, this is just a few decades after the start of the experiment. So a couple other relevant historical events during this time. In 1964, Lysenko is finally deposed. So some of this research starts getting out to the rest of the genetics world. He's very excited about it. And in 1970, Trout starts breeding a line of aggressive foxes as a parallel experiment, which will be relevant in just a second. So moving on to the 80s and 90s, the fox experiment is still going strong. There's a huge wealth of data being collected. There are many studies. These are just a few of them. So this study in 2004 found that the tame foxes showed higher levels of serotonin, which is associated with mood, and lower levels of cortisol and adrenaline, which are associated with stress, than the control group. And if you remember, these are some of the same hormones we see implicated in dog evolution, which is kind of neat. So these next two figures are looking at significantly different gene versions and gene expression between tame and aggressive foxes. Excuse me, sorry. So these are 1, 2, 3 genes that are all expressed in the brain. We're not really sure what they do yet, but this one on the right is probably involved in neuronal development. So there's a version of this gene that only shows up in the tame foxes and a couple that mostly show up in the aggressive foxes, which is interesting. And then as far as cooperative behavior goes, the tame fox puppies cooperate with people just as well as dog puppies do, and significantly better than the control foxes. So this constellation of traits led a group of researchers in 2014 to propose this domestication syndrome theory, in which all of these characteristics are linked at the neural crest, which is a stage in development when the brain and spinal cord are developing. So if we can hop back to 1961 for a moment, this was the year that Ludmila Trout started noticing changes in the attitudes of the workers at her fox farm. So they were starting to pet and spend extra time with the tamer foxes, clearly forming bonds. For example, there was one worker who would always bring her breakfast to work to share with her favorite fox. And at first, Trout really saw these interactions as a problem because she wanted to be careful that the foxes weren't just imprinting on people. She didn't want to skew their data. But as time went on, she realized that the urge to interact might actually be a finding. So basically, these foxes were developing such appealing behavior that people could not resist them, which she hypothesized might have been an important step in dog evolution too. So on that note, zooming back out to dogs, there's evidence that dogs have developed traits specifically to manipulate us, which if you own a dog is probably not too surprising to you. So this study in 2018 found that when you make eye contact with your dog, your brain releases oxytocin, sometimes called the love hormone. So basically dogs have figured out how to hijack the bonding mechanism that's usually reserved for human-to-human bonds. Another study in 2019 found that dogs have evolved these highly specialized facial muscles, giving them much more control over their facial expressions than wolves. So it's pretty possible that the puppy dog eyes are actually a trait they evolved to get more attention from us. It's probably more fair to think of dog domestication as a two-way street. So they evolved to work with us, but we probably also evolved to work with them. And there's actually a long list of genes that show parallel selection in humans and dogs, such as those involving starch digestion, neurological processes, and adaptation to high altitude. So basically, as we moved into different areas, started eating new foods, trying new things, dogs were alongside us doing the same stuff. And I will leave you with a quote from the book Le Petit Prince that Ludmila Trout has cited as a guiding influence in a lot of her work. And on that note, I know there were a lot of cute fox pictures in this talk. Please don't go out and try to get one. Unfortunately, they do not make very good pets yet. Give it another 20 to 30 generations, we'll see. And the answer to the question you've all been waiting for, there were 8 hidden dogs in the talk. But don't worry if you missed any, because you can go ahead and catch them now. And with that, I am happy to take any questions.
Hello, everyone. Have you ever wondered how we can harness the absolute power of waves, that raw ebb and flow? Well, we are about to embark on a wild ride to explore the wet pulse of big wave energy. To start, hold on, sorry. You're going too fast. To start, my name is Nic Ulm. I'm an ocean engineer at the University of Hawaii, investigating how wave energy can be used for non-residential power. My main focus is on a device called Halona, which is a mobile wave-powered ocean observing platform shown on the screen here. The platform uses wave power to charge unmanned submarines that explore the ocean. In other words, I use the power of moving fluid to dock shaft-like objects that pass power and data back and forth by being tip to tip. This big wave energy allows us to explore deep into the oceans for longer than ever before. But before I get to the good stuff on how to use big wave energy, you have to get wet with me. So, what really gets me going is, the raw beauty of waves. And so, what I'm going to talk about right now is my drinking game. So, with the drinking game, when I get wet, you drink. Sounds good? Perfect. So, this is Nazaré, Portugal, which has some of the biggest waves in the world. And what happens here is you have immense storms off the coast of Portugal in the Atlantic Ocean that whip up these waves. These waves change both in size and shape, where when they feel the bottom, they actually go and change. So this is known as shoaling. And so as the bottom rubs up against these waves, pushing them towards the spot, and you can see on the screen here this canyon. So it pushes it towards this single point, and they get really big, like 80 feet big. This picture is taken from on top of a cliff. This 80-foot slab of fluid is one of the wildest rides that you can ever do. Just imagine hundreds of gallons of gushing white foam thrusting forward as you ride this hard piece of wood. That salty spray getting everywhere, all over you, but you don't care. It's just pure bliss. It's the best ride of your life. And you're just going faster and faster just to complete this wave and complete this ride. But the question is, now that you've ridden the biggest, will the small waves ever be enough to satisfy you? Now, as much as I enjoy the ride, it's not always about being on top. What I find beautiful sometimes is the view from below. So what you're seeing here is an underwater vortex. And so when the wave curls and barrels like that, it traps water underneath the surface. And as it turns and churns, it actually traps the air in what looks like a little mini underwater tornado. So aside from when the waves interact with air, I really love when waves actually interact with other waves. And you just have these two moving fluids colliding with each other, combining their energies until it can't be contained and it just pops. But what even is a wave? So common misconception. Waves are not inherently the motion of fluid. It's the transport of energy within that fluid. So if you track individual water particles in a wave, it would move in a complete circle. That water particle is bumping up against the fluid next to it, giving its energy back and forth, thrusting forward and backward, moving up and down in this circular motion. And so by understanding how the fluid is moving in different settings, you can learn to harness it. And it doesn't always move in perfect circles. Sometimes it really just moves back and forth. As it gets shallower and shallower, in the second image you can see the sandy bottom acts like a barrier, forcing the water to be really just a forward and backward thrusting motion. That's the stuff that surfers like. But you have to conserve momentum. So that energy being condensed, it has to become shorter and really thicker. And so that wave gets so dummy thick that it can't contain the energy anymore, and it has to release it, which is when the wave breaks. So that dummy thick wave releases its energy into turbulent white foam. And when you see waves barreling, it's actually the water particle on the wave moving faster than the wave itself. And so it's really just throwing itself out there instead of being turned into turbulent foam. And it creates this beautiful barrel. And those barrels of spinning fluid are perfect for just getting deep in there. You have that slab of water throwing itself over. You're trying to see how deep you can get inside there without losing control. The wave's spitting spray and saltiness, and that barrel just starts to close out and fill up with fluid, and that's when you know it's time to get out of there. So now that we understand the basics of waves, now we can look at where they're useful. But before going in too deep, I want to answer a question that might be on your guys' mind, which is why wave energy and where can it be used? So wave energy is fairly global. In a literal and philosophical sense, wave energy is condensed solar energy. So as the sun disproportionately heats the earth, it creates these different temperature pockets of air with different pressure. And so you have a pressure gradient where it goes from high to low. And so that air is induced into flow. And when that occurs over the ocean, that wind blows across the top of the water and transfers that energy into the waves. When this occurs, the energy is condensed at each step. So most of the wave energy is actually a lot more bang for your buck in terms of unit length. So if you compare wave energy to solar energy, wave energy is about 10 times more dense than the sunniest day, even on a small to moderate size seas. And so with how the wind blows, you actually have a higher energy density towards the poles. This high energy density waves can be extremely powerful. But like anything, going too hard can be dangerous and destructive. So you really got to be prepared and use appropriate protection. So now to the good stuff, how to use it. Depending on where you are in the wet world and what sort of activities you're into, wave energy can provide your power needs. In the past 50 years, wave energy has primarily focused on powering residential homes, but as I will get to later, it hasn't quite taken off yet in comparison to wind and solar. And it's because it's so bloody expensive. But wave energy can be used for a lot more than just powering a light bulb. It can be used for powering navigation buoys, where now you have ships that are completely autonomous and don't have people on board. It can be used to sustainably do aquaculture, where you have these fish farms that are powered by wave energy devices, and those wave energy devices make sure that, there's robots that can be powered that will go and make sure the fish are healthy. And it can be used in emergency disaster relief or to create fresh drinking water. Finally, the biggest thing is that we can use it to produce hydrogen fuel. And so for the entire transportation industry, they can shift from a cheaper hydrogen-based alternative. Because wave energy can be captured in so many different ways, the opportunities for it are immense. This takes me to the fun part, how it works. So, like I mentioned before, waves in shallow environments, it's a lot more of that back and forth motion. And so what you see here are these flappy flaps that protrude when the wave goes and hits that massive amount of fluid against the body, it goes and rocks it back and forth. And so that dangling back and forth can be used to push a piston that pushes fluid into a turbine and generates electricity. So this one is called the FOSWEC, or the FOSSI. It's from Oregon State University. And what this type of wave energy converter is really good for is actually producing fresh drinking water, which we actually are on a project right now. This big Portuguese sausage is known as Polaris. It's a behemoth. It's known as an attenuating wave energy converter, and what it is a bunch of these cylindrical shafts that are connected at hinges, and as they kind of rise and fall and undulate with the motion of this fluid, that relative motion allows them to go and pump pistons, which pumps fluid into a turbine, generates electricity. And these attenuators can produce a lot of power, but they're also size queens. They gotta be big. The typical size of one of these baddies is about a full football field long. These devices are great for producing power in energetic seas, because you need size to survive in the biggest waves. And this brings me to a point that I was going to make earlier, is that it's so expensive to just have that much steel. But big waves can induce what is known as a large structural load. If you're going to make something capture the largest waves, it has to be able to take the biggest loads. So that means, to be safe, you make the device as big as possible for the average large load size that you're going to see. This device is called the OPT power buoy. It's known as a point absorber. So it absorbs all the wave energy at a single point. The way that it works is you have this donut-like buoy that wraps around this large shaft, and it kind of just does all the work where it's moving up and down, and that large shaft is lazy and it just kind of sits there. And inside that shaft, you have what is known as a ball screw. And that ball screw moves up and down on this rotating shaft, and it turns it. And so that turning, rotating shaft turns a generator and produces electricity. This device is used in oil production. So at the very bottom of the ocean, they have a docking station where unmanned vehicles go and dock. And those unmanned vehicles go and inspect oil rigs, which is necessary for environmental protection. But these unmanned vehicles can be used for a lot more. These devices are typically deployed in a mid-depth application. So if you think at the full ocean depth, which typically is about 3 miles down, if you were to have something where it's producing power at the very top, and it's 3 miles down that you're going and having this thing, so you, all the way down you hit this large dangling cable that's traveling 3 miles, that can be really expensive when it breaks. So this next buoy, this buoy is called Azura. It's a rotating mass point absorber. The way it works is that you have these 2 large legs that protrude out of the water, and this dangling rotund mass that's hung between the legs. As the wave passes, it lifts it up and rotates it, and then it slams it back down, and that turns a shaft, which then turns a generator and produces electricity. So this was actually deployed here on Oahu, just off the Kaneohe Marine Corps base, at a test site called WETS, the Wave Energy Test Site. This is primarily going to be used for residential power because it's surprisingly efficient at capturing wave energy. This next one is the Fred Olsen Boltz Lifesaver. It's a type of point absorber. This device was deployed here as well. It's tested at WETS, and we tested it to produce power for ocean observing sensors to see what the environmental impact of wave energy is. This whole large wet hole generates electricity by being tied up and tied down to the bottom. At 3 different points, there are cables that stretch down to the bottom, and as the fluid pulses it up and down, you have those cables pulling and turning a winch, which turns a generator and produces electricity. This buoy kind of highlights another major issue in the ocean. So it's a dirty mistress. This big wet hole accumulates salt and algae all over it. You can see it. And if it isn't properly maintained, you have these long strings of algae just hanging in the current off this hole. And this actually can affect how it moves in the ocean and can cause performance issues. So it's important to keep that hole clean and working well. So now I've talked to you through what the industry uses. I want to talk to you about some emerging technology that I'm working on. This is called the Halona. It's known as an oscillating water column device. It's based on the Halona blowhole over by Sandy's Beach, hence its name. And it's intended to be a drifting buoy that docks with unmanned vehicles to observe the deep ocean for longer than ever before. And when I say that, what I mean is the current methods of observing the ocean rely on ships. And so these ships are limited in how long they can be out there due to human safety concerns. And this can be costly and limits how long they can be out there. So it can cost about $200,000 for 2 days of ocean observing. So if you do that for a 6-week period, which is typical, it's about $4 million. So by being able to charge a vehicle without the restrictions of oil or concern for human safety, we can observe the ocean almost indefinitely with extremely high resolution in terms of time and space. But enough about that. I'm not trying to kill the mood. Halona works by taking the large surging mass of fluid inside a hollow shaft to compress air. So it goes up and down, it compresses this air, and as it forces this air through a small hole at the top, now you go and put a fan there, and it captures this high velocity energy, and voila, you have electricity. What's interesting about this device is that it doesn't really want to move. You take all this high energy fluid, just slam against this hard floating body, and it'll barely move. It'll move a couple centimeters, which is kind of cool because it becomes a lot easier to dock things to it when it's trying to meet up. But like I said for Pelamis, you have to appropriately design this device for the biggest load that you expect to take. Most wave energy converters are designed for longer period swell, those beautiful curves you can watch for miles from away. To avoid too much water ejecting out of that hole at the tip of the buoy, we've designed the buoy to only work in shorter waves. So those quick, choppy movement waves, those waves that aren't really good for surfing, such that the stroke is fast and small, quick motions, not those long, slow strokes. Long, slow strokes make you blow your load, blow too large of a load. Sorry, getting hot and bothered here. Now, these small, fast strokes don't have as much power, but for charging vehicles, we aren't looking for a whole lot of power. We're looking for predictability and consistency. Long, slow strokes only happen seasonally when you have the right large storm events. Those quick, small strokes are available year-round and are created nearby. So as long as the wind is blowing, you know you have the right type of waves. But unlike wind energy, even if the wind stops blowing, those waves are still going to continue on. So you'll still have a consistent amount of power. So the predictability and the consistency is a lot higher than that of wind and solar. So with a combination of consistent, predictable power and stable buoy motion, we can enable an ideal ocean observing device. And that isn't how I intend to use big wave energy to go deep into our oceans for longer than ever before. Thank you for enduring this wet-ass power generation presentation. And now I need questions.
Everyone, give a warm welcome to Val Alvarez.
Hi, everyone. So my name is Valentina Alvarez, and I am a PhD student here at UH Manoa. But what I'm about to talk to you about has nothing to do with that. This is other stuff that I've been involved with since I moved out here. And my talk isn't really as lighthearted as the last talk, but maybe drink when you feel sad or when you learn something new, because hopefully you do. So I moved to Hawaii a little bit over 2 years ago, and what I've learned throughout my time here has really impacted my life and like the way that I see the world. And having never been to Hawaii before I moved here, I expected this. And though it really is this beautiful here, and I did get this, I also got to quickly see a side of Hawaii that the rest of the world seems relatively unaware of. So a few days after landing, the only person I knew on this island invited me on a trip to Molokai. And little did I know I was being roped into a weekend of community service. Though I was upset at first, I am now so incredibly grateful for this trip. And I found out that we were to spend the weekend cleaning a beach on the north shore of Molokai called Mo'omomi. And I'm from Florida, so I've done some beach cleanups in the past, and what I expected to find based on that were like cigarette butts, cups, bags, things left behind by beachgoers. But really, what I ended up finding was more like this. This is actually a picture from that weekend. And what I learned over the next 2 years changed my life incredibly. And I don't think that at any point in my life have I had such a drastic change in the way that I see the world. And today I want to share that with you all. I want to share what I've learned since I've moved here, so that we can all become aware and hopefully inspire some of you to make some changes. So the plastic problem here is quite interesting. So it's not like what I mentioned in Florida, because as you can see, this isn't mostly household goods that we're all familiar with. These are actually things that probably most of us have never really handled. These aren't things that have been left behind by beachgoers. This debris actually has a much more complex story behind it. Most of this debris does not even originate in Hawaii. And though we're one of the most isolated land masses in the world, somehow we get hit with marine debris originating in very distant places. And these are all photos from Molokai. So we see microplastics in the ocean, in the waters nearby, in the sand, and a bunch of different varieties of plastics. I'll get a little into this a little bit more in a second. So to understand how this rubbish ends up on our beaches, we first have to think about where we are in the Pacific Ocean. So globally, there's 5 ocean gyres, and simply put, these are just large systems of rotating ocean currents. As we all know, we are here, which places us in the North Pacific Gyre. So these spinning gyres across the world cause an accumulation of marine debris that we've come to call garbage patches. And the most famous of these garbage patches lies in the North Pacific Gyre, where we are. And it's actually right here between Hawaii and California, and we call it the Great Pacific Garbage Patch. But patch is actually a pretty misleading name since it's more like a plastic soup that extends from the seafloor to the surface of the ocean. And the plastic particles in the patch range from sizes of microplastics, like less than 5 millimeters, to huge conglomerates of abandoned fishing nets, which we call ghost nets. So these nets that are either like thrown overboard or left behind, either purposefully or inadvertently, can become huge conglomerates, and these make up the larger patches of the larger pieces in the garbage patch. And though we can't really get an exact estimate of the size of the garbage patch, estimates claim that it's about 1.6 million square kilometers, or twice the size of Texas. And this is this is actually taken in the Great Pacific Garbage Gyre, and this is what we call a ghost net, a huge conglomerate of nets. So because of our location in relation to the spinning gyre of plastic, the islands act as a filter or a comb in the center of the gyre, and we catch marine debris from these currents. In addition, we get these strong and consistent trade winds that hit the northeastern coasts of the islands. And because of that, all of our northeastern shores get hit the worst. And we end up with coastlines that look like this. This is another ghost net that ends up on exposed coral. We get beaches that look littered in buoys and other marine debris, and more. We can see tires in this photo, just a variety of marine debris that's originating from other parts of the world. We also get microplastics, and we might sometimes encounter things that are familiar to us, like household products. But usually when we pick these items up and we look at them, we can tell that they didn't originate in Hawaii because they're so old, or they're brands that we don't recognize, or they're written in different languages. And all of this is a product of our location in the garbage gyre. So all of these products that you've seen in these photos, the buoys, the traps, the nets, the household products, the bottles, the tires, no matter what part of the world they originated from, they all last long enough to make it to our shores because they're composed of plastic. So now, what is plastic really, and why is it even a thing if it does this? Well, in 1869, John Wesley Hyatt received a New York firm's $10,000 reward for creating a substitute for ivory. His invention was synthetic plastic, and this material was praised for relieving our impact on nature, as it was inexpensive and could be molded to replace items that were previously made of wood, metal, stone, bone, tusk, and horn. The idea with this product was that it would help protect the natural world from the destructive nature of human consumption, which is pretty ironic, as you'll see. And so through the years, plastics began to be used for many different things. And the use of them in World War II is credited for one of the largest surges of plastic production. So here, this is John Wesley Hyatt. These are plastic producing factories during the war. This as well, this is virgin plastics being produced. Canteens that were previously made of metals were now being produced as plastic. Other advertisements during the war for different materials that could be useful in the war. So after the war, plastics hit the consumer market. They replace traditional materials such as paper and glass in packaging, wood and furniture, and steel in cars. The throwaway lifestyle was created. Housewives were targeted with the idea that their house chores would be cut down significantly since they could now just throw everything away and not have to clean anything up. So the problem with that, and something that these corporations undoubtedly knew, is that a way does not exist. Is this a way? Or this? Or this? And though it may be obvious to see that this is definitely not good, I thought I should probably point out why it isn't. So now, why is plastic bad? So I came up with 4 reasons that off the top of my head that I thought were important to mention, but there's obviously a lot more reasons. But so firstly, plastic is a material that was designed to last forever, and it does just that. As plastic photodegrades or is broken up by UV rays, it only becomes smaller and smaller. Plastic breaks up, not down. Secondly, with research that was published here actually at UH Manoa in 2018 by Dr. Sarah Jean Royer, it was discovered that as plastics photodegrade in the environment, they release harmful greenhouse gases such as methane. And it was also discovered that the most common forms of plastic, like plastic bags and bottles, release the most greenhouse gases of any plastics as they photodegrade. Third, through direct contact with ocean plastics, wildlife ingest the plastics or become entangled in them. And lastly, and aesthetically, plastic leads to a loss of our pristine coastlines that are such a huge part of our lives here in Hawaii. So is there hope for the future? Well, I volunteer with Sustainable Coastlines, and what we do is organize large-scale cleanups. And we use these cleanups as an education tool to teach people how to take care of their coastlines and inspire change. So at our cleanups, we can make coastlines go from this left picture to the right picture. But obviously cleaning up is not the answer. And we try to teach that at all of our cleanups. So what we really need to do is to stop it at its source. So what can you do? Well, first off, maybe don't purchase items like these that just don't make any sense. And if you see items like these, support them. And those are 2 ways of voting with your dollar. But another really important way to vote with your dollar, and something that's really relevant here in Hawaii, is to know where your seafood comes from. And fish is obviously a really big part of the culture here, and such as like poke, but really most of the poke that you're purchasing, if you're purchasing at Foodland or where it may be, oftentimes it's not sustainably sourced. And as we saw in the pictures prior, most of the debris that we get comes from these fishing industries. So there is a really good resource called seafoodwatch.org that can help you find the most sustainably sourced seafood. So another thing that you can do is vote by actually voting. So when legislation arises at a local, state, or even a federal level, get out and be heard, testify, and vote. In Honolulu, we had a recent victory with the passing of Bill 40. So this bill addresses land-based plastics like takeout containers and utensils and bags, which are more of a problem at our town beaches, since, as I mentioned earlier, marine debris hits the northeastern shores the hardest. Another thing that you can do is volunteer. Come out and help us get rid of these ghost nets. There's nothing like seeing this firsthand. It really is inspiring. And of course, educate others. Spreading awareness is a really important thing. And before I go, I wanted to share some other like victory that is just happened this year. So the Clean Water Act requires that the EPA designate impaired water bodies that do not meet the state water quality standards. The problem is that the EPA does not consider plastic a contaminant. So the Center for Biological Diversity Sustainable Coastlines Hawaii and Surfrider Foundation joined forces to actually sue the EPA for ignoring evidence of plastic pollution in 17 bodies of water in Hawaii. So after an investigation by the EPA, 2 Hawaiian bodies of water were listed as imperiled due to plastic pollution. And now both of these beaches are included in water quality management plans, which is actually, it might not seem like a big victory since it's just 2 of the 17 bodies of water that were listed. Plastic pollution was never listed as a contaminant, or was never considered a contaminant before. So this is like a huge stride in the right direction. And with that, I can take any questions. If you are all feeling inspired to get involved or to learn more, you can follow our Instagram page at Sustainable Coastlines Hawaii. We also have a Facebook page, and you can get enrolled in our email listserv to find out about upcoming events. Obviously everything is a little bit different now because of COVID, but get involved. If anyone has any questions, I can answer them.
Yay!